Hey everybody, this is Chris with Overclockers Club. Are you ready to take a look at a new cooler? Yeah, it's time for something new here, but did you catch the manufacturer there? G.Skill. I mean, when you think of G.Skill, what do you think of? You think of memory, lots and lots of memory, but it looks like they are jumping in to the world of liquid cooling, and they're starting off with a 360 millimeter radiator. Everybody and their brother has a liquid cooler now, so what can you do to set yourself apart from everybody else? Well, it looks like G.Skill is taking the approach of going with increased radiator tube density, so we'll look at that in more detail. We've got 9-blade cooling fans. Let's see, enable RGB lighting. So these different manufacturers, you can synchronize this cooler with these motherboards, so that's nice. And then looking at the rest of the specs here, what stands out is the pump speed is 5,000 RPMs, and since that's a single number, that tells me that it probably runs at full speed off of like a SATA power source. 5-year warranty. It looks like all of the major sockets are covered with the exception of the TR4 for like your Threadripper CPUs from AMD. Speed on the fans, we got 2100 RPMs. That should move a fair amount of air. And nothing else terribly exciting there. So let's get it out of the box. And the box is open. Got a little warranty guide there. Here is the quick start guide. It's always good to sort of go through these and familiarize yourself with all of the different components that are included, all of the installation steps, especially for your particular socket, because you don't want to mess up your installation. And we got 3 fans. These are 120 millimeter 9-blade fans. 2100 RPMs. I'm a little surprised it actually shows the RPMs on the fan. 12 volt, 0.23 amps. And these are 4-pin PWM fans. They have nice braiding there on the fan cables. And they actually have the name right there cast into the side. And let's see, there are 4 little rubber isolator pads on each face at the corners. So that's nice. So we got 3 of those. Let's see, I should be, oh, here we go. So they put 2 in there and 1 off to the side. Okay, so all the fans are accounted for. This is probably the hardware box. It's pretty heavy and I can hear stuff rattling around in there. So yeah, these are all your components for your installation. So we have the fan screws, washers, spacers, some springs there, mounting screws, bracketry for an Intel installation, bracketry for an AMD. Oh, this actually does have TR4 installation brackets there. Okay, well, this must have happened after they had the box art printed up, so that's nice. And now we can get the radiator and the pump out of the box. And I just popped the little cover off here. We'll put that back on for the moment, if it'll stay. Good enough. Okay. So anyway, this is the radiator, and what I find interesting right away when you look at it, you can see there's definitely an appearance of higher density. So if we look at the number of tubes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 tubes going across. Now I want to measure the thickness of the radiator, and my calipers, problem I have here is my calipers can't get past the thickness of the frame. I can't squeeze down any closer than the frame really. But what I can do is I've got these little pieces of aluminum that stick out further than the radiator frame on both sides. So what I can do is put these in the calipers and zero it on these 2 little aluminum pieces, and then place one on either side And now I measure across the top of the aluminum. And since I zeroed out on the aluminum, this measurement is taken, and it will be just like the aluminum is not even there. So I'm getting about 16.16, 16.2 millimeters is the thickness of the radiator. And looking at the pump in more detail, it does have the white thermal paste already applied from the factory here across the copper cold plate. And it's got a protective sticker over the RGB face there. Now, the cooling lines here, get this flipped over. The cooling lines are braided and appear to be pretty thick. In fact, let me zero this back out. They are roughly about 14 millimeters in thickness, in diameter I should say. And they swivel over here at the base of the pump, so you can see they're made to move around. And we have two leads coming out of the pump. One is a 4-pin PWM, so I was wrong about the SATA interface. So this will plug into your fan header, or your pump header I should say, on your motherboard, and we'll see how easy it is to control the pump RPM. And then this is your RGB connector. So this would connect to your motherboard. Notice that there are only three. There are four total points there, but there are only three that are active. This one right here is actually blocked off. So we have two on one end and one there. And it's very important. If you look, there's a little arrow right there, and it's very important when you connect these things that the arrows meet, because that is your 5-volt power source. Now, looking at the radiator itself in a little more detail, you can see the way the hoses are terminated there to the radiator. Now, this particular radiator does not have a fill port. Used to be the only radiators you really saw with a fill port that were not your all-in-one. They were your custom cooling radiators where you build the whole system. And I've seen a few all-in-ones that have fill ports, and this one does not. Not saying that's a good or bad thing. Just something, if you're interested in a fill port, this one doesn't have one. If you don't care, this one doesn't have one. So it doesn't really matter either way as far as how the system will perform. Alright, so I guess really the next step is to get this thing installed on my test system. Alright, ready to do the installation here. I got the stuff out of the Intel bag, as you can see there. And the base plate here is flat. Now sometimes these base plates have some weird bends to them, and there's, they can go on this way but not that way, but this one here is flat, so it really doesn't matter. A couple of these little cross brackets here. A couple of washers. It says Intel 2011 on the bag here, but it looks like they're used even on this socket here. Now this is a 9900K on a Z390 motherboard from Intel. Okay, these are the studs, and it comes with, so I got the little studs here, and those go on the plate. But what's interesting, there are these 4 little O-rings, but then there's this little blue tape here that has these little tiny little washers, and I'm not sure what they're for. It doesn't show them anywhere on the instruction sheet here. I looked through all of the items and I don't see them listed, and I don't see it anywhere in any of the steps, so I'm not sure exactly what those are for. But anyway, we'll continue with the installation. Now you can see there are 2 little punch outs there side by side, and since we're using an 1151 socket, we use the punch out that's closer to the inside here, not the outer one. And then these little O-rings here, they go on, if I can get them out of the bag. They go on to the stud. They push over it like that, and that's what sort of holds it in place. That way, once you get it on there, the stud won't fall off. So we do that to all 4 corners. Push a little O-ring on there. Okay, wants to stick on there. That's fine. And let's see, the other O-rings. That one goes on there. And then the fourth one goes in there like that. Oops, O-ring's coming off of that one. Alright, so you end up with a bracket that looks like that. All four of the studs are on there. So that goes up from underneath. Now the CPU still has thermal paste on it from the last test, so I'll have to clean that off here in a moment. Still would like to know what those are for. I'll set them off to the side. So these push up from underneath. And I made my little motherboard tray here tall enough that this should go right in. Like that. So you can see the studs all poke up through there. But actually, in the accessory bag here, I should have gotten these out ahead of time and I didn't. They're little plastic spacers, and these usually have enough interference that when you put them over the studs, it keeps the studs from falling back down through the motherboard like they just did, because I did not have these ready. And there's also a tube of thermal paste here, and I'll talk about that extra tube there that they included here in a moment. So these do have a little bit of a okay, so if you look inside there, it's a little hard to tell, but there is actually a little shoulder in there. So it looks like, okay, maybe it doesn't matter. Okay, according to the instructions, there's nothing showing that one side is up or down, so I'll just disregard that little shoulder in there. And then these brackets go over the top, and then finally they get screwed down at the corners with, let's see, there should be 4 of these. Now we're not using these studs here. These have the coarse thread on one end with a larger end and then a smaller, finer thread. We don't use these. That's for a socket 2011. Alright, so now I push this back up through. And then the plastic spacers go over the top, and they do not have any interference, so what you'll have to do is use one hand if you have it sitting flat, if you have your motherboard flat, and then the brackets. So what we need to do is, okay, so if we want the pump to go sideways like that, we'll put the brackets like this, and then a stud pops through there, and we put the little fastener over the top. And I don't tighten these down until I get everything set up and in position, because it looks like things are going to have to shift around a little bit to find the sweet spot where everything fits. And another thing I'll mention here, it's a good idea to use an anti-static wrist strap if you're anywhere where there's any risk of static, or if it's the time of year where the air is dry, or you're working on carpet. Now this tabletop here is stainless and it's grounded, So my risk for a static discharge is pretty minimal. Okay, so that's the initial installation, and now I'll get the CPU cleaned off. So I got the CPU cover there all cleaned off, and the next thing here is to get the pump on. Now, one thing, if you noticed earlier, I pointed out that the pump has this factory installed thermal paste, but it also has this tube here of blue thermal paste that is also included. Now, I'm not 100% sure that it's going to come this way retail all the time. I don't know if eventually they're going to switch over to just supplying this paste in a tube, and then the copper plate there will be bare, or if you'll always get it this way. Don't know yet, but I'm going to test it both ways and see if there's any temperature differential between this white factory installed paste and this blue paste. And the big thing to keep in mind anytime you do an installation is really take your time, don't be in a hurry, or you make mistakes, because I've done that many times, and it's usually because I'm in a big hurry. Now, this is the hardware that will clamp the pump down or attach the pump. You got a couple of these shoulder screws, a couple springs, and then a couple washers. And you want to make sure you use these washers here. But these washers are supplied, and they go down there first, and then the spring, and then the fastener. So I'll get the pump in position first. And it really doesn't matter what the orientation of the pump is. So for testing, it doesn't matter to me that the logo there is going to be sort of upside down. But we want to get that in position. And it looks like it's where it needs to be. And we'll put one washer down. And then one screw with the spring. Get it started, and you don't want to screw it all the way down. You just get it started on one side. Do the same on the other side over here. And, whoops, see, I already dropped that washer. And let's see if I can get that out of there with a magnetic screwdriver. Alright, so that worked. So first the washer, then the spring, and the ends of these springs are ground, so they're flat. That way when you put the screw through there and screw it down, you get nice even pressure. There, so that one is started, and then we'll go and tighten them equally. And they should bottom out, and that way you know they're done. And then I just give them just a little snug, and then I come back and make sure I get the ones here on the corners. Again, I alternate. I don't tighten them all down together. Or I should say one at a time. That's what you don't want to do. You want to sort of alternate here. And that helps to put a nice even amount of pressure of the pump, of the hardware that holds the pump in place. That puts even pressure down on top of the CPU. And then as soon as those get snug, and you can tell when you've sort of bottomed out there. Alright, now, of course, the header here, this is for the RGB synchronization, and then this one here, this is your power to the pump. The 4-pin PWM, pulse width modulation. Most modern motherboards, especially gaming or performance motherboards, have a dedicated header, one of your little headers here that's specifically for the pump. And over here there's one that says AIO all-in-one pump. So that's where I'll plug this one in. And then for the motherboard CPU, or not CPU, RGB synchronization, there's a header here, that's for like an LED strip. There's one over here for an LED strip on this motherboard. And there's actually one that's dedicated that has the 3-pin, here it is, it's over here. that mates up with that particular socket. Alright, so now I've got to get the power supply hooked up, get the fans on the radiator, get it booted up, and then get all the system set up to do the stress testing. And I have it powered up, and I'll look into what it takes to get the RGB on the pump there synchronized with the motherboard. I'm doing the fan tuning right now. Anytime you add fans or put a new cooler on, you always want to try and do your fan tuning. And here's the spec sheet that shows the test system. As far as pump noise and vibration, I mean, I can tell that it's on, but there really isn't any vibration to speak of. I can feel a little bit through the tubes. Again, just enough that you can tell that the pump's running, and I can hear it if I get right up next to it, but that's running at full speed. And I just went in and got into the ASUS Fan Expert software here, and I can adjust the pump curve here, which is pump speed versus temperature. So as the load on the system and the CPU temperature go up, well, your pump will follow this curve. The RPMs will follow that curve all the way up to 100%. And so right now I'm running at about 2400, 2500 RPMs, which is about half the speed. So that just shows that I can adjust the speed of the pump based on system load. So right now at 2400 RPMs, there's pretty much no vibration and no sound at all. So again, the system is at idle. I'm running right around 30 degrees Celsius. And like I said, I can come in here and grab these set points and move them wherever I want. And that will adjust the behavior of the pump under the different conditions. So part of the process of fan tuning, it runs the fans pretty much from their highest RPM to the lowest RPM, and then the fan curve, there we go, then it fires it up to the high, yep, and then brings it down. Alright, so the fan tuning is done. Now I need to get the configuration going to do the overclock, which is going to be at 4.9 gigahertz. Seems to be the sweet spot for this processor and motherboard. And then we'll use AIDA64 to stress test the CPU and pump some heat into the radiator there. The overclock is cranked up, and I have the fan speed maxed out, so they're running at about 2100 RPMs. Now, if you recall earlier, I talked about how the pump speed was 5000 RPMs, and I wasn't sure if you could vary it or not, and you can. So right now it's running at about 2400 RPMs, and the temperature has gone up a bit, but I can actually change the profile here of the pump, and the temperature has gone up a few degrees. So, and again, I'm just kind of playing around with it to see how it responds, but I'll pump the, or crank the RPMs of the pump back up to 5000, and we'll let the coolant sort of thermally soak there so everything's up to temperature, and then we'll see how well it maintains that temperature. And I keep the room temperature at about 68 degrees Fahrenheit, which is about 20 degrees Celsius. I knock the RPMs of the pump back up, and you can see the temperature dropped a fair amount again. So if you want to adjust the curve for the pump based on temperature, you can do that. A quick anatomy lesson on radiators. There's actually a little baffle here. It's not quite in the middle. It's sort of a 60-40 split. But one side is where the warm coolant comes in, and I can feel it's this side here. So the warm coolant comes in, and it travels down one side of the radiator. So it goes all the way down one side, hits the bottom tank, changes direction, sort of does a U-turn, and comes up the other side to where it exits. And of course the idea there is for it to be cooler when it exits than when it went in. And I can feel a difference. So the path that your coolant takes is really not just 360 millimeters, it's 360 down and then 360 back. And I'll get the thermal camera out here a little bit, and you can sort of see the temperature differential between the two sides. The other thing I want to say is all of these radiators have a little bit of air in them, and you have to have the air to compensate for the expansion of the coolant inside when it gets hot. And the air usually goes to the top of wherever your tanks are. So this is actually not the most ideal way to mount your system. You always want the pump below the inlet and outlet. But the best way to mount it is actually with your radiator inlet and outlet, and that's sort of an orientation there at the bottom. That way any air goes to the top and it doesn't get sucked in to your pump. Because if you have your radiator in this type of an orientation, if there's, the amount of air varies, but if there's enough air in there, it could get sucked into the intake and you'll hear the cavitation in the pump. You'll hear the bubbling and the gurgling. Now I haven't noticed any of that with this particular system, so there may be just a very small amount of air and it's staying at the high end of the radiator here, but just so you know, you really want to mount it so that it's not like this, where these are at the very top. Ideally you want them down or facing down like this if you have it in your case. That's better too. So it's been holding at about 56 to 58 degrees, so I guess you could split the difference and call it 57, which is pretty typical for what I see with a triple fan 360 millimeter radiator. And now it's time to take the pump off, get the thermal paste, the white thermal paste cleaned up, and try some of this blue thermal paste and see what difference, if any, there is in the temperature. Now, when you take the pump off, be careful because remember these washers here are loose. And let's see if I can get that off there. You don't want these washers to fall off and land on your motherboard, and then if you forget about it, you fire up your motherboard. It's not good to have metal pieces like that floating around, so just keep an eye on them and make sure you put them back when you reattach the pump. So I have all the old paste off of there. It'll be interesting to see how much of a difference, if any, there is. Now I tested some Noctua, I believe it was NTH2. They make an NTH1 and an NTH2, and I tested it a while back. And I don't remember there really being a big difference. Maybe a degree. I don't remember if it was actually as much as 2. I'll have to go back and look. And I know there are thermal pastes that are better than others, but anyway, alright, we'll get this together. Alright, so I got the thermal paste on there. We're putting everything back together. Now if you have a computer that's several years old, it's a good idea to check your thermal paste because it does have a tendency, some thermal pastes I should say, have a tendency to dry out, get kind of hard and cakey. They crumble if you take your cooler off and check them out. And a good indication is if you're just sitting there at idle with no load on your CPU and the cooler isn't, you know, all fuzzed up and dirty, and you're looking at your idle temperatures, and if you're idling at like 52 degrees C, you might want to pull the cooler off and see if you're due for a fresh application of thermal paste. So I'll get these tightened up and then we'll turn it on, get the heat going, and see if there's a difference. And now we're running with the blue thermal paste, so we'll let everything get up to temperature for a little while and see if there's any difference. Now the thing with testing coolers is you have to keep all of your variables the same. So I have to make sure I always use the same motherboard, same CPU, same room temperature, same overclock settings, same software to stress test it so that it is as apples to apples as possible, and keeping the room at the right temperature isn't too bad in the winter, but the summer it can be more of a challenge because my air conditioner sometimes struggles to keep the temperature the same. And the temperatures seem to stay between 55 and 57, so I would average that at about 56. So there's about a degree difference maybe with the blue paste. Nothing huge, but I'll take every degree I can get. Alright, so it's time to break out the thermal camera and take a look at the radiator. And like I was telling you earlier, you can see clearly one side, get my hand out of the image there, one side is the hot side, so that's where the warm coolant is coming in at the top there, and it makes its path all the way down to the bottom of the radiator. Getting the coolant line in the way there. Makes a U-turn where it comes back up to the top, and it should drop a few degrees before it exits and goes back to the CPU. And we can see it here on this side where the fans are. You can see the hot spots where each fan motor exists there in the middle. And again, there's the top of the radiator. You can see the warm spot there on the left compared to the right. And this doesn't really tell you anything particularly interesting, just you can see the heat distribution on the radiator, and they all pretty much look the same way. And another quick look at the motherboard, so you can see the pump there. Nothing real exciting with it, nothing unusual. You definitely see the heat on the motherboard there. And the heat of the power supply. But looking at the coolant lines here, you can clearly see which one's bringing the hot coolant in and which one's taking the cool coolant back. And it's decibel meter time, so again the fans are cranked all the way up, so this would be worst case. We'll come around to the other side. And also keep in mind that when your cooler is in a case, that tends to deaden some of the sound depending upon how you mount the radiator and of course what case you use. And in case anyone was wondering, ENKI was the Sumerian god of water. So this is available in 3 different flavors. You can get this in a 240 millimeter radiator, a 280, and of course this one is the 360. So what did I like? What did I not like? Well, I like the compact size of the pump. I like the way they did the RGB across the face there. I like the large diameter lines here, tubes. They are 8 millimeter on the ID, which is nice. I like the copper base plate on the pump. I like the fans. They seem to move plenty of air and do so without generating too much noise. I like also the way I can control the pump speed. I also like that, so it's not just screaming at full speed all the time. And really the only thing I would change, I would probably include one of those 3-way cables so I can connect all 3 fans into one header on the motherboard instead of having to find 3 headers, because sometimes you don't have 3 available. So that's really the only thing. And you can buy those little 3-way connectors. They're not terribly expensive. So really overall, I would say G.Skill's entry into the all-in-one cooling market is a success. I think it's a decent cooler, and I definitely like it. Oh, I also forgot here, it does come with the additional thermal paste. This is like a server grade thermal paste. So from what I can tell, it does look like it's going to come with the included thermal paste already applied to the pump, and then this is also going to be supplied. And don't forget, this is the highest density radiator here with the most tubes, 16 tubes of any of the coolers that I have ever seen. And one more thing, I know I keep saying that, but talking about the cold plate here, this is the surface that touches your CPU, but if you flip this plate over and look at the back side, they actually form these little steps or little fins there, and that increases the surface area, which gives the coolant an even greater opportunity to be in contact with the copper that is pulling the heat away from the CPU, and then the coolant can pull the heat away from the copper. So having said all of that, I would have to give this the Overclockers Club Gold Award. Even though right now I don't have any pricing, my guess is to stay competitive, especially with a first release like this. The 360 millimeter model here, my guess is somewhere in the $100, $120, maybe $130 range. Of course, they always have sales and things like that. As soon as I do get some firm pricing, though, I will post it in the description. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.